Well, now we're going to talk about solving log equations, and we have a series of, guidelines that I like to go through whenever I do it, or maybe I'm breaking it down and identifying what type of equation I'm solving to know how to proceed. The first one we're going to look at is this scenario right here. If I only have one log in my equation, then we're going to use our definition of logs to rewrite it as an exponent and then solve. And remember, all I did was write right here just our definition of logs. This says y is equal to log base a of x if and only if, that's what IFF stands for. It looks like a typo, but it's not. If and only if base a to the y is equal to x. That was our definition of logs. And if you see these two examples that we're looking at right here, notice that I only have one log. The word log is only in here once even, and that's so we're going to use our definition to be able to solve it. To do that, we're going to start with the equation over here, example 3a. And I have log of x plus 6 equal to 1. My log term is all by itself, so I can immediately just head on into rewriting this in its exponential form. And so this is going to be, let's start with the base. What's the base of log? That's log base 10. So this is going to be 10 to the first power is equal to the argument x plus 6, and just like that we got my variable x out of the argument position, and I can solve for x. I'm going to subtract 6 to both sides, and I find out that x is equal to 4. So that's a pretty fast way to solve it. Let's look at this next one. This says 7 plus 3 natural log of x is equal to 6. Again, I only have one log term in my equation, and so I'm going to use the definition of logs to rewrite it as an exponent. To do that, I have to get this portion by itself. So I'm going to subtract 7 to the right hand side first. So that's 3 natural log x is equal to 1 by subtracting 7, or negative 1, excuse me. Now again, I'm trying to get the ln x by itself, so I'm going to divide both sides by 3. So this is ln of x is equal to negative 1/3. Now that I have my natural log or my log portion by itself, I can use the definition of logs to rewrite this in its exponential form. So this is a base e, because the natural log is log base e, raised to the negative 1/3 power equal to the argument of x. And that's it. That's all we had to do. This is the exact answer, and if I wanted to put that into my calculator, I could find out the approximate answer on this one.